So let's take what we just reviewed, which is this idea that the instantaneous rate of change looks like f of a plus h minus f of a all over h. And in order to approximate it, what we were doing was we were taking really small values for h. But now that we have limits, we can actually build this in a way where we'll be able to evaluate it directly. So right now we're going to focus on writing an expression. So let's write an expression to evaluate the instantaneous rate of change of f of x equal to 2x squared minus 7x plus 4 at the point x equals 2. And remember, instantaneous rate of change occurs at a specific point, in this case 2, which is the value of a that we're going to be looking at. So when I build this, I'm going to look at f of 2 plus h minus f of 2 all over h. And this is what we did in that topic 1.1, where we started off where maybe h equaled 1. And you did f of 3 minus f of 2 over 1. And then we did 0.1 and then 0.01. The nice thing now is that now that we know limits, we can actually look at this as h approaches 0 by simply taking the limit as h approaches 0. And think about what we get here. If I just substituted 0 in, I get f of 2 minus f of 2, which is 0, and I get 0. I get that indeterminate form. So I'm going to be able to apply some of our techniques to potentially evaluate this limit and come up with an answer. And in fact, that's what we're going to focus on. We will focus on evaluating this expression algebraically in some later topics. But for right now, the key to this lesson is understanding that this expression right here is going to allow us to actually evaluate and find the instantaneous rate of change of a function at a given point. Rather than building a long, tedious table that only approximated it, we're going to build a simple limit statement that's going to be able to allow us to evaluate this instantaneous rate of change directly.